I want to make computers that are faster and capable of storing more information, and I want to use materials that shouldn't even exist. But how and why? Well, we all want our new computers to be faster and capable of storing more data, more pictures from our holidays, funny cat videos. We want to store a lot of data and be able to access it really fast. Unfortunately, our new computers will soon stop getting any faster because we're reaching limits of how much better we can make computer chips. Hard limits imposed by physics and money. Now, we do want and need more computational power, so what can we do? Well, at the moment we're using binary system, which just means we have 2 bits that we can use for computation, 1 and 0, which in essence just means on and off. But what if we can have more bits? What if we could have our conventional 1s and 0s, so on and off, but also different bits like up and down, left and right? 6 bits might be better than just 2 bits. But how do we get materials that have 6 bits? Well, I work with a very special material that exists in only 2 dimensions. This material has 1 layer of tungsten, which is a metal, sandwiched between 2 layers of sulfur, which is not a metal. And these materials, or rather elements, are quite common, but in the form I'm using them, they're just 3 atomic layers thick. That is 100,000 times thinner than a strand of human hair. And this extremely thin sandwich of tungsten and sulfur actually does have access to these 6 bits. So on and off, up and down, left and right. And this might help us build better computers. Now, it's probably very difficult to imagine such a thin material because we live in a 3-dimensional world. Everything around us has certain height, width, and depth. But my material is a sheer surface. It lacks 1 whole dimension, has no depth. Think of it this way. If you take a post-it block note, it's a very nice 3D material that you can hold in your hands with certain height, width, and depth. But if you take a topmost post-it note, just this topmost note is my material. Now, despite being so improbable, this material actually does exist. And the only thing left for us is to figure out how to combine it with our current existing technologies and how to tune it in a way to give us highest boost in computational power. Because reality is, our modern world is based on data and computation, and with each passing year, our computational needs are growing more and more. And this quite common but improbably thin material might just be the solution to that problem.